Good evening. This will be the last reminder that when you walk in, make sure you scan that QR code. That is how I take attendance. That's how I record it. So this evening, we're going to review what should be chapter 1. We're going to review the techniques of evaluating antiderivatives of trigonometric functions. Why? Because the next technique that we study is trig sub, which involves converting a function into a trigonometric function. Sine squared. We just did integration by parts. And so if you wanted to, you could use integration by parts. Or you can remember the reduction identity for sine. Sine squared is 1 minus cosine of 2x all over 2. Antiderivative 1 is easy. What about cosine of 2x? What would the antiderivative of just cosine of x be?
Minus sinus?
What is it?
Minus sinus?
You did the derivative.
What is it? The question?
Antiderivative of cosine. So the derivative of cosine is negative sine. That's not the antiderivative. You just need one slight change.
Negative.
That's what it said.
Plus c?
It's positive sine for the antiderivative. But this is of 2x, right? So u sub, you let u be 2x, you're going to wind up having to multiply by 1/2. And then don't forget that constant of integration. Now I'm going to rewrite it this way. That would be acceptable. But for trig sub, that sine of 2x is a pain. We don't want it. We want to write the antiderivative in terms of single angles. So we don't want sine of 2x, we want sine x, cosine x, tangent x. So I'm going to have to rewrite this to involve trig functions of a single angle.
Two sine x plus sine x.
What is it?
2 sine x multiplied by 2 sine x.
Right, so sine of 2x, double angle formula, the double angle identity. 2 sine cosine, and of course 2 over 4. Right, either one of those would be acceptable. Like I said, when we get to trig sub, I'm going to have to write it this way to proceed. Sine squared was easy. What about sine cubed? Sine cubed, isn't that sine squared times sine? And isn't sine squared 1 minus cosine squared? What is the derivative of cosine? So derivative of cosine is what?
Negative sine.
Negative sine. Oh, look. Sine x dx. U sub let u be cosine. And we get a negative. This becomes 1 minus u squared, right? This is the same as u squared minus 1, get rid of that negative. So I'll start with the antiderivative of u squared, which is what?
U cubed over 3.
Then minus antiderivative of 1. And then your constant. Remember, you have to now back substitute.
Can we, like from the beginning, just replace sine squared with the answer in the first question, and then just take logarithm from sine?
So you can't, I assume you mean this part here,
Yeah.
right? You can't, because this is a product, right? You can't split antiderivatives across multiplication.
Mhm.
only addition and subtraction. Right? So if that was sine squared plus sine, then yes, you're done, right? You already get this answer. But because it's multiplication, you can't do that. If only it worked that way, it'd make antiderivatives a lot easier. Much like x plus y all cubed, it'd be so much easier with just x cubed plus y cubed. Sadly, it's not. Still not too bad. Okay, it's this one next. What about sine squared times cosine cubed? So here's where the technique comes in. When you're dealing with antiderivatives involving sine and cosine, products, sine and cosine, look for the one that has an odd power. In this case, it's going to be cosine. Split it. And by pulling out one of the terms. So in this case, we're going to pull out one cosine, we're left with cosine squared. Derivative of sine is cosine, so we're going to want to do a u sub with u being sine. But we have that cosine squared. So then use the Pythagorean identity, sine squared plus cosine squared equals 1. U sub, let u be sine, we get u squared times the quantity of 1 minus u squared. And then this is just simple power rule. What's that antiderivative?
U third power divided by 3 minus U third divided by 5.
And don't get the constant. And then back substitution. We said u was sine. There your antiderivative. Notice here sine was odd power. We did the same thing, didn't we? We took one sine, used the identity, then did u sub. If both powers are odd, you have your choice. You can either split sine or cosine apart, doesn't matter. Kind of about the same procedure. If they are both even, you cry. Then you have to pick one to use the Pythagorean identity on. I think I actually have the case where they're both even. I do. one to use Pythagorean identity on, distribute through, you can't use U sub. You're just going to have a bunch of either sines or cosines with even powers, and then have fun from there. What about sine to the fourth? So the power is not odd, meaning we can't use this trick here. Integration by parts again would work. You could let u be sine cubed, dv be sine. But sine to the fourth. Isn't that sine squared squared? And what did we do with the sine squared example?
1 minus cosine squared.
The very first example.
Like 1 minus cosine 2x.
Right? We used the reduction identity. Half squared is a quarter. I'm just going to take care of that quarter right now. Now we have to expand this out. Do you remember that formula? A plus b quantity squared, or a minus b quantity squared? I think all your algebra teachers are very sad. A squared minus 2ab plus b squared. 1 minus 2 cosine 2x plus cosine squared 2x. Up to the fifth power memorized. These are actually very easy to do if you know Pascal's triangle. It goes on forever. Can you see the pattern? So what's the 8th row?
Eight.
Where?
What is it?
Where's 8?
Just like the first one is 8.
First one.
2, 3, 4, 5, 9.
There's an 8 in there. It's not the first one. It's 1.
Oh yeah. 24.
No. 28. How'd you get it?
I just saw that a moment ago.
What's that? There's 28.
56.
56. Then what?
70. 28. Yeah.
No, not 28.
No, it'd be. 56 again.
56. Then
28.
and 8.
And then
1. Each entry is the sum of the two diagonally above it. Pascal's triangle has another unique property. Every single number you see in the triangle is a binomial number. Eight choose 4 is 70. So the 8 4 binomial number is 70. Look at the expansions. Look at Pascal's triangle. Fifth power coefficients. 1, 5, 10, 10, 5, 1. Look at the fifth row of Pascal's triangle. 1, 5, 10, 10, 5, 1. I can now easily expand out A plus B to the 8th power without having to do any algebra. That's going to be more useful than you realize. By the way, A plus B squared, if you look at the second row, 1, 2, 1. All that has to change is if this is a minus, plus minus, plus minus, plus minus, that alternates on. Start with plus, and then alternates plus minus from there. We still have a problem here, though. It's cosine squared. Can't have that. You're going to have to use the cosine reduction identity. Cosine squared theta, 1 plus cosine of 2 theta all over 2. That makes that cosine squared 2x 1 plus cosine 4x all over 2. One plus a half. 3 halves, right? Antiderivative of 3 halves. Antiderivative of cosine of 2x already did. Half sine of 2x. Now times 2. Antiderivative of cosine 4x. Using the same logic, it would just be a quarter sine of 4x, wouldn't it? You sublet UD4x. Then times a half. And we'll just try to have enough room to put plus c there. Distribute that 1/4 through. And there's your antiderivative. This one's really fun if you have to break this down into single angles. Sine of 2x isn't bad. Let's just do the sine of 4x. You have to do double angle. Two sine 2x cosine 2x, right? Well, the sine 2x, double angle again. Two sine x cosine x, so now we have 4 sine x cosine x, but we have a cosine of 2x now that we can't have. What's the double angle identity for cosine?
Sine squared minus sine squared.
That's 0.
1 minus 2 sine squared.
That's one of them. So 1 minus 2 sine squared would work. There's 3 total. 2 cosine squared minus 1. And then cosine squared minus sine squared. Which is the most accepted one. typically the one that we use. And if you want to, you can distribute 4 sine cosine cubed minus 4 sine cubed cosine. And then of course you have to plug all that back into here with the sine to just replace. So hopefully we won't see anything like that when we trace up. Or you hope that I'm not evil enough on a quiz or a test to say, write your answer in terms of single angles.
I'm sorry, could you, in the example on the left, in the second to last step, could you say again where the 3x over 2 came from?
So I did 1 plus a half, right? Because this here is a half plus a half
Oh.
cosine 4x is 3 halves.
Okay, thanks.
And then just that.
Thanks.
I was just running out of room, so I didn't do that intermediate step.
That's okay.
So if you get something like, actually it's going to be our next one, right? Sine squared, cosine squared, you're going to kind of see what we're going to have to do. If this was sine to the 6x, you follow the exact same procedure, except this becomes cubed now. This would then be cubed. And you have to expand it out. Then you're going to have a sine squared and the cosine squared in there, and the cosine cubed, which is easy enough to do. But then that sine squared, cosine squared, you're going to have to use the reduction identity. And you can see how hideous it's going to get to do by hand. Again, or you could just use integration by parts, which is just as hideous. Let's up the ante. What if you get sine times cosine both with even powers? I'm keeping it simple here, where they're both just squared. If one of them is squared, happy day, because that's the easiest possibility. Since they're both squared, it doesn't matter which one we pick. I'm going to pick cosine squared here. There's a method. This. So I'm going to keep sine. Rewrite cosine squared as 1 minus sine squared. Distribute that sine squared through. This is why I changed cosine and not sine. Antiderivative sine squared we already did. It was the first problem we looked at. What was it? You don't have to give me the reduced form. With single language, you give me the one with the double angle.
So x divided by 2 minus sine of 2x divided by 4 plus c.
And I'm going to ignore the plus c. Antiderivative sine to the 4th. We just did. So it's going to be minus this. And at the very end, put our constant in. There's our antiderivative. Simplify. Actually, I want to simplify. These two can be combined, right? And these two can be combined. That's nice that these two are actually drop out. We get what? X over 8? They drop out, then just minus sine of 4x over 32. That's a constant. There's our antiderivative. If neither are squared, you have to pick one. Good rule of thumb, pick the one with the lowest power, in this case cosine. Cosine squared is 1 minus sine squared, so that would be 1 minus sine squared squared. Span that out, distribute the sine through. You're going to have a bunch, you're going to have sum and differences of sines to even powers, so you just follow this procedure for each one. So, that's why I said if they're both even, you cry. Because it's just long. Yes. And obviously, we have squared, and then you choose the one that's squared to replace with the Pythagorean identity, and then proceed. So those are integrals involving sine x, cosine x to powers. Questions there? And notice, by the way, that is all pre-calc. And then some calc 1. Right? It's just trig identities and then calc 1. That's why this should cover calc 1. These are all technically calc 1 integrals. What if we have sines and cosines of multiple angles? Should have these I can never remember off the top of my head. These identities. And so remember, there is a table of all the trig identities posted on Teams that you're allowed to use. I do recommend we print those tables out. Maybe. Could be E won't use green. That'd be fine. Let me write came out first, so the one I'm using. The identity for sine alpha times sine beta. This is a product to sum identity. Typically, one of the very last things you do in pre-calc. There's your identity. So now you should see how we're going to proceed with these types of antiderivatives. Use the product to sum identity. Then on 1/2, factor it out. Cosine of 3x minus 2x. Cosine x minus cosine of 3x plus 2x. Cosine of 5x. Antiderivative of cosine. Just sine, right? So what is the antiderivative of cosine 5x going to be? Let's take a shot at it.
Sine x to the 6 over 6 for cosine of x.
You mixed the power rule and x and the power rule.
Is it either 5 sine x 5x or 1/5 sine x 5x? Or sorry,
Yes.
sine, no, not sine x, like sine 5x.
Yes, it's one of those. Which one?
For 1/5.
Oh, wait. Mistake. Where's my mistake?
Over 10.
Should be over 10. Right, because that's you multiply by half. There's your antiderivative. Now, here's the good news. When we do trig sub, we will never get situations where it's sine times cosine of multiple angles. It'll always be sines, cosines, secants, tangents of single angles. So I'm not going to worry about breaking that down. I'm just going to leave it like that. Because that sine of 5x is a pain to break down into sines and cosines of single angles. You have to do a product to sum backwards for that one. I think that one is, no, I'm sorry. It's the sum identity for sine. Sine of theta, sine of alpha plus beta. And then you have to do a double angle identity for both sine and cosine. It's just a freaking nightmare. So, in fact, I did break it down in my notes, and it's about half page. Let's break it all down. So, just pretend. honestly don't know why some people like chalkboards. They're awful. But whiteboards are pretty go. Sine of 3x times cosine of 5x. So guess what we're going to do? Product of sum identity. This one we're going to need the identity sine of alpha times cosine of beta. 1/2 sine alpha minus beta plus sine alpha plus beta. So 1/2 sine of 3x minus 5x. Sine of negative 2x. Plus sine of 8x. It is convention that you don't have negative angles. Well, I don't want to say that. I mean, you can have negative angle, but when you're writing as a function, you don't want your angle function to be negative. It's just custom. So we wouldn't write sine of negative 2x. There are two identities. It's not really two, it's one group of properties for the trig functions that are very often forgotten, but extremely useful. That's the even and odd properties. Cosine is even, sine is odd. In fact, cosine and secant are the only two even functions, the other four are odd. Meaning, I can rewrite sine of negative 2x as negative sine of 2x. So this is the same as this. Now it's just simple. What is the antiderivative of sine of x?
Minus cosine divided by 9.
Be just negative cosine of x, right? So then what is the antiderivative of sine of 8x? We've got negative cosine 8x over 8, right? And then times 2, or times the 1/2. What about sine of 2x? What is the antiderivative of sine of 2x?
Could be plus cosine 2x.
Be what?
Plus cosine 2x divided by
are you incorporating that minus?
But if from sine is gonna go to minus cosine.
Yeah, so that's why I'm asking you, incorporating that minus to make it plus?
Yeah.
Then yes. And then, of course, times a half. There's your antiderivative. Just as personal preference, I don't like negatives out front. So I would write it this way, but it doesn't matter. Reading through, someone's a math major. When you do this long enough, you're also going to come up with these pet peeves. Like mine is, I don't like having negatives out front. You're going to have. Just wait till you hit the level 300 courses. They're fun. I believe I also saw you do have another degree, right? What was it?
Business.
Are you going to do any kind of stat courses?
Well, I did test 1 and test 2.
Yeah, as a math major, you can also minor in stat.
Here,
Not here, when you transfer to a 4-year,
when I'm planning on majoring like financial mathematics or quant finance.
which means you should take some upper level stat courses as well.
Yeah, I guess.
Those are also quite fun. I regret not doing that. And you have a graduate degree, or you're in grad school,
Yeah.
and they're making you take a undergrad class.
I'm just doing it because my degree is only going to be like middle school math, and I want a high school math degree, like to teach high school math. So that's why I'm like going back and taking. I need to take like 12 credits or something.
I would just tell you to get a master's in math and teach it at college. Or do the backdoor route where you get a master's in math and then do the backdoor certification. So you don't have to worry about an education degree at all.
Yeah. Would that be like a lot of math classes though?
Because you have to get a master's in math.
Yeah. I don't know if I'd be able to like.
And
pass
master's
that.
in math programs, assuming that you've taken a bachelor's in math. So you've taken real analysis, you've taken modern algebra, you're familiar with proofs.
Yeah. Maybe one day.
Cosine 4x, cosine of 2x. Again, it's another product to sum. There's that enemy. All right, so replace the integrand. 1/2, factor it out. Cosine 4x minus 2x plus cosine 4x plus 2x. And now it's just antiderivative cosine of 2x. Sine 2x over 2 and times a half. Cosine 6x, antiderivative sine of 6x over 6 times 2. Add your constant. There's your antiderivative. By the way, if you get cosine times sine instead, there is technically a product to sum identity for that. But multiplication is commutative. So I would just rewrite it to be sine times cosine and use that identity.
How do we get this, the cosine 6x?
Cosine of 4x plus 2x.
Okay.
That's this piece here.
Can you go over it one more time? I think I got lost from.
I'm just using this identity.
Okay.
What's alpha? 4x. What's beta? 2x. So using this identity, right, so you know where the 2x came from, right? It's now just 6x, right? Because you're now adding the 2 angles instead. So that finishes up sines and cosines. Good? Excellent. So good one that involves a tangent. There are 3 broad categories. Products of sines and cosines, products of tangents and secants, products of cotangents and cosecants. I believe even in the video, I've left the cotangent and cosecant method to you to figure out, because it is very similar to the tangent secant one. Right, but I do detail that procedure, along with the sine and cosine, the products that we just did. I give you a detail, step-by-step on how to do it. Where do you think we're going to start?
We could rewrite it.
As what?
Tan 2x squared. Yeah, we just square instead. So we get even one more.
So you said this.
Yeah, or we can also we can make it odd, right? Do 3x and then times tan. Like the same thing, just tan 3x times tan. No, just that.
Right, so I think you're confusing, this is a power.
Mhm.
This isn't 4 times x, this is tangent of x all raised to the 4th power. That's not correct.
Maybe sine over cosine.
Could, you get sine to the 4th over cosine to the 4th. How would you proceed from there?
From sine squared
you do after that?
Can we take derivative from there, or antiderivative or no?
Because it's quotient, so again, you won't be able to do it. You'd have to do a u sub, which wouldn't work.
Maybe we can take the denominator and put it on top just with minus negative power.
That would still lead to the same issue. You'd have to then do integration by parts or a u sub, which is a lot more work than we want. It does work, but it's just going to be a lot more work than you want to do. Start by writing as tan squared times tan squared. Where do we want to go from here? What is the identity, Pythagorean identity with tangent in it? Tangent squared plus 1 equals secant squared. Let's rewrite one of those tangent squares. Distribute the tangent squared through. Uh-oh. This is a problem. That tangent squared is a problem. So we write it again. What is the antiderivative of 1? Just x. Antiderivative of secant squared. Just tangent. What about here? Well, if the antiderivative of secant squared is tangent, then what's the derivative of tangent?
Using the tangent squared and then
Derivative of tangent would be secant squared, right? This is a u sub. Let u be tangent. There's your secant squared. What's the antiderivative of u squared? Because this is u squared du. So what's the antiderivative of u squared?
secant to the fourth.
You went too high. So you cubed over 3, right? You just look at power rule, u squared, integral, you cubed over 3, u is tangent. So it's tangent cubed over 3. And there's the antiderivative of tangent to the fourth. And so integrands that involve tangent secant, a little different than sine and cosine. Because you have to remember, if you're going to do u sub, derivative of secant is secant times tangent. The derivative of tangent is secant squared. So if you want to do the u sub with tangent, you need a secant squared dx. If you want to do u sub with a secant, you're going to need a secant times tangent. Okay, so we do have some time left over, so let's take a look at some homework. There are 2 ways we can proceed. Go this way. Use the reduction identity. So reduction identity for sine. Sine squared x equals what?
1 minus the sine 2x divided by 2.
We're going to have a half. 1 minus cosine of 12x dx. Antiderivative cosine of 12x. Sine 12x over 2. Or, not over 2, sorry. Sine 12x over 12 times a half. Sine 12x over 24. The other way you could have done it use u sub. Let u be 6x. And you get a 1/6 sine squared u du, and then proceed from there. This is what? U over 2 minus sine of 2u over 4. Right, that was the first problem we did tonight. All that times 6. U over 12 minus sine 2u over 48. No. 6 times 4 is 24, not 48. U is 6x, x over 2, minus sine of 12, x over 24. And so it's just where do you want to do your u sub, first or after using the identity. Either way, we get the same thing. So 2 minus sine 12x. Yay. We need to get out of this one. What's this antiderivative? It shouldn't require any work. If you are going to do work, it is basic.
Negative cosine to the fourth x over 4 plus c.
This is just a real basic U sub right up front. I like when I get these ones like that. Oh, this one's fun. Okay. There's one thing I have to write down. What are we going to do first?
Odd.
Hmm?
Odd power.
Because this is now sine cubed, not just sine. So it's not going to be, it's not as easy as the last one was. So remember the strategy. Which one has an odd power? So pull out a single sine. Now what?
U sub.
What would your U be?
Sine.
What's the derivative of sine?
Minus cosine.
Just a regular cosine. We have cosine to the fourth. So we have a single sine. Which function has sine as its derivative? Cosine, right? So you're going to want your U sub to be cosine. But you still have that sine squared messing things up. What do you do? Right, so we don't want to keep this sine. So this is safe. You want that sine x dx in there, but we don't want that sine squared. We only want cosines now.
Well, minus cosine 2x. Or cosine.
Right, 'cause you said that, which I don't think you meant.
Yeah.
Cosine squared. And then you do U sub. I'm not going to write out the U sub. Actually, what I'm going to do is I'm going to multiply by a negative and flip the order. Right, because we actually want a negative sign for derivative cosine. You can think of these now as just u's. U to the sixth minus u to the fourth du. What is antiderivative of u to the fourth? Nice. What is it?
For u cubed.
You gave me derivative. Anti-derivative.
To u fourth. U fifth divided by 5.
And u is cosine. Wait a minute. Check on this so I don't confuse myself. I was shooting that negative through again. I didn't want to do that. So that should be that term there. Antiderivative of u to the sixth.
So.
That should be our antiderivative. Okay, I'm gonna have fun. I think that's gonna be wrong.
We forgot minus sign.
I think they were capital C, not lowercase c. I'm gonna test it. So you're all safe. If this makes me lose my perfect score. This is for science. Oh wait, no, not CD. Oh wow, it actually did accept it. Nice. I've run into some of them where it didn't accept it. And they didn't tell you in the problem use capital C. So if you want to be safe, just always use capital C instead of a lowercase c. Unless the actual instructions tell you otherwise, right? They might tell you to use K as the constant. Let's get about this button here. Okay. Just keep in mind, notice when I'm entering the answers, I am putting parentheses. Or I'll do sine and then parentheses x. It actually does that automatically, I believe. But when I write it out, I don't use parentheses. What do you think we're going to have to do? You could.
But we should, it's not like you should.
So the problem with that is this isn't a product of two signs. This is a product of three signs. So yes, you could. Two ways you can do it. Sine x times sine x times sine of 2x, or you use the reduction identity on sine squared first. Then distribute through, you're going to have sine of 2x minus a sine 2x times sine 2x, which is then where you use the product to sum. But there is an easier way. I'm pretty sure that is, the product to sum is not the intention of this problem. You're overlooking something. What does sine of 2x equal?
Sine x cosine.
What is it?
2 sine x cosine.
2 times sine times cosine. And now that's not what I can do in my head. What's the derivative of sine? So the derivative of sine is what?
Minus cosine.
Not minus cosine,
Just cosine.
just positive cosine. U cubed du, u to the fourth over 4 times 2. U to the fourth over 2. So sine to the fourth over 2. Yeah, say, typed in x and automatically put parentheses, which is annoying. And don't forget the plus c. Right, so if you did the product to sum, you get that with a lot more algebra. Seriously? Oh, that one's easy. Actually, I could have just looked up there, huh? That U, R, and G. Random number gods. They must have shined on me. Now watch, none of you will get that lucky when you go to do this. Oh, okay, well this one's also kind of easy. So write the integral of tangent to the 15th in terms of the integral of tangent to the 13th. not asking us to evaluate it, thankfully. You are. So, for odd power of tangent, you want to pull out a tangent squared. Because that's going to allow us to write this. Tangent squared is secant squared minus 1. Distribute that tangent through. Okay, so there's that term. That stays. And it's going to be minus. Right? They don't want us to evaluate this, thankfully. What is the derivative of tangent?
Secant squared.
U to the 13th du. So there you go. Tangent of the 14th x over 14 minus that antiderivative. They should not require a constant in this because we still have antiderivative in there. There you go. You can imagine how much fun you'd have if they actually wanted to fully evaluate that. Right, because then you do the exact same thing on tangent to the 13th. Right, tangent to the 11th times tangent squared, which becomes secant squared minus 1. So you have a tangent to the 12th over 12 minus the antiderivative tangent to the 9th, 11th. And then you have to do that again. You have a 9, and then you do it again, you have a 7th, and you keep doing that until you got rid of it. What does the next one look like? Nice. This will probably be the last one. Well, cosecant to the 11th times cotangent cubed. Okay, so they are both odd. So here's what I'm going to do. Which function, cosecant or cotangent, has the derivative of cosecant times cotangent? So what's the derivative of cosecant? Cap 1 instructor is very sad. What's the derivative of secant? Secant and tangent behave similar to cosecant and cotangent. Very sad. Derivative cosecant, negative cosecant cotangent. Cotangent squared. 1 plus cotangent squared equals cosecant squared. That is the third Pythagorean identity. Which means cotangent squared is cosecant squared minus 1. Notice I made this negative by also factoring out the negatives. This bit here is our du. It's u to the 14th minus u to the 10th du, which becomes a simple power of 1. And again, notice I flipped the order because of that minus. Uh-oh. Plus 2 is 12, not 14. Minus 2 points from everyone for now. Noticing that. Questions on trig integrals? Brush up on your trig. Because on Monday, we do trig sub, which means we're going to be doing a bunch more of this stuff. Except for cosecant and cotangent. They don't show up in trig side. Not usually. They can, but they usually don't. But we're not always going to get things that look like this either. We may get things like sine times tangent. And so we need to be very comfortable with our trig identities. Also on Monday, the first quiz will be handed out. So that's exciting. 2 weeks already. Have a wonderful weekend!
Is the quiz take home or?
It'll be taken. See you Monday evening.